Okay guys, sorry I'm not in class again today. I had a field trip that I forgot about, but here is the lesson. I'm actually going to do two of the lessons if you printed off the notes. I'm going to do the geometric figures continued, which starts with this warm-up, and I'm going to do the distance from a point to a line. So the first one here, we've got Susie has figured out all the side lengths and slopes to this shape, kind of shown below. And we want to use what she's found to conclude what type of quadrilateral this is. So looking at it right away, you can see all the sides are the same, so that realistically only means it can be one of two shapes. It's either going to be a square or a rhombus. But because we don't have negative reciprocals, we just have negative values of the slopes, they're not 90-degree angles, and therefore this shape has to be a rhombus. Alright, so looking at more geometric figures, these are just some examples of what we were doing before. Verify that XYZ is a right angle and then classify it as scalene, isosceles, or equilateral. I'm going to do it all at once. There's two ways you can do it. You can either find the slopes for the first part and see their negative reciprocals, or check Pythagorean theorem. So I'm just going to check using Pythagorean theorem, so that means I need to find the length of all the sides and then plug in with Pythagorean theorem. So if we look at xy, so again just looking at these points, we've got x and y. I'm using this formula, 4 minus 2 squared plus 1 plus 2 squared is going to be 2 squared is 4, plus 3 squared is 9, 9 plus 4 is 13. Then we're going to look at x and z. So we're going to have 4 minus 1 and 1 minus 3. So 4 minus 1 is 3, that's negative 2. 3 squared is 9, negative 2 squared is 4, 9 plus 4 is 13 again. So it's at least isosceles because we know two of the sides are the same now. The next side we look and we see we've got 2 minus 1 and negative 2 minus 3. So we get 1 squared plus 5 squared, or negative 5 squared. So we get 1 plus 25, which is 26. And so we know that this is an isosceles triangle. It's got two sides that are the same. And we can use Pythagorean theorem to see a squared plus b squared equals c squared. Root 13 squared plus root 13 squared equals root 26 squared. These square roots and squares cancel each other out, so we really have 13 plus 13 equals 26. And that's true, so this is a right angle triangle. Alright, consider ABC, and we've got A is negative 3, 6, B is 1, negative 6, C is 5, 2. We need to find the midpoint of AB, which is M, and then the midpoint of AC, which is N, and then we need to verify that 2 times the length of MN equals BC, and that MM and BC are parallel. So first we need to find our midpoints using this formula, x2 plus x1 over 2. So M is just going to be negative 1 and 0. All I've done is plugged in the points exactly. I'm not going to go through it, but I just took the points here, plugged them in exactly. And N is 1 and 4 using the exact same thing. And I'm showing you all my work, I'm just not going to go through the whole thing. After that, we need to find the length. So we're going to use the length to find the length of this. But we actually need to find 2 times the length of MN. So I've put a 2 in front of the square root, and it's going to be 2 root 20. Because we get 4 minus 0, 1 minus negative 1, which is actually 1 plus 1. So we get 16 plus 4. 16 plus 4 is 20. And we leave that 2 in front. And I'm not going to do anything. This could become 4 root 5 if you really want to, because it would be 2, and then another 2 and root 5. But we'll just leave it like that. Our next formula here, we've got negative 6 minus 2 squared plus 1 minus 5 squared. We get root 80. Root 80 is actually root 4 root 20, which is 2 root 20. And that's why I just left this first one, because I knew that that would happen. Therefore, they are the same. Alright, well now we gotta check our slopes. and see if they're parallel. The slopes, remember I told you this before, the slopes are actually right there. There's delta y over delta x, delta y over delta x. So we get 4 over 2, which is 2. Negative 8 over negative 4, that is also 2. You can probably hear my dishwasher emptying in the background. Alright, distance from a point to a line. Okay, now this is a long process. So if we're looking at this, there's happy Mr. Shaw, and I'm going to trot over to this line. Do, 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 do. Not very straight, but it should be. Because if I don't draw an exactly straight line, I'll straighten that out there. If I don't draw a straight line, let's try to get it on those dots. And if this doesn't come in at a 90-degree angle, I'm actually taking the hypotenuse to the line. And remember, the hypotenuse is always the longest side of a triangle. So I want to make the right angle so I'm not on one of the hypotenuses from that right angle. If I take anything other than the right angle, you can think of me drawing a triangle from that right angle. So I need to take that line. With that being said, the first thing I need to do is find the slope of this line. So how far from the road if you're at point -1, 3, so that's -1, 3, and the road is this, so this dotted line we'll say is that equation. So the first thing we need to do is find the slope of the line and then the perpendicular slope. The slope of this line is an easy rearrange. We just leave y there, move the x to the other side, move the 6 to the other side. And you'll notice if you printed these off, that used to be a 5, I made it a 6, so that the numbers work out a little nicer later in the question. So we've got y equals -x plus 6, and a slope of -1, so our perpendicular slope is 1. From that, the next step is going to be find the equation through that point. So we've got our slope of 1. We know our point is -1 and 3. Oops. So we need to then use y equals mx plus b, plug in, find our b value, and find our point. After that, we need to, this is the hard part, we need to find the point of intersection, and it's come back. This is what we did at the start. This is why we do it. Point of intersection of this line or this one, it doesn't really matter. If you rearranged wrong, then the rest of your question's wrong. So you can use this line and this line. So we got to find the point of intersection, because that's actually the point we're going to measure from back to the point that we're standing at. So I just made y equal to y by doing substitution. -x plus 6 equals x plus 4. You can see I've already started solving for y. I would move this over here and get 2x equals 2. I just switch the sides. You can do this and make it a little easier, I guess. Make it look a little nicer. Wow. Well, that doesn't look nice at all. Just kidding. There we go. X equals 1. And then sub in to find y. So y equals 5, so our point of intersection is 1, 5. So what that means is we've actually found the point right here. That's the point of intersection. That's the point we just found. Now with that point, if we want to find out how far we are from the road, we need that point, because now we know the point we're standing at, which is -1 and 3, and we know the point of intersection. So now we can just use our length formula and find out how far we are from the road. So we get our length formula, plug in, and we find out we're 2√2, I guess units. It's probably going to be meters away from the road in this case. Okay, and here is all the work. This is geometric figures homework. This is point to a line homework. And again, you have all the information now. I think you needed point to a line to finish one of the questions on the assignment, but now you have all the information for the assignment. Good luck.